7.5 Complex Numbers in Polar Form, De Moivre's Theorem, Day 3. Your learning goal is that you will be able to represent complex numbers and their operations on a complex plane. In this lesson, we're going to learn how to multiply two complex numbers in polar form and divide. So let's start off with multiplying. We're going to let the two numbers be represented by Z1 and Z2. And so in order to find the product of Z1 times Z2, and let me just point out this is the polar form. Then in order to multiply them, you're going to take R1 times R2. And then on the inside, you're going to do theta 1 plus theta 2, cosine of that, plus I sine theta 1 plus theta 2 for your sine value. And you're going to leave your answer in polar form. So let's apply the formula. For example 1, we're given Z1 and Z2. So to find the product of Z1 times Z2, this is multiplied. We're going to do R1, this is R1, this is R2. So you're going to do 4 times 7, and then you're going to do cosine. This is theta 1. It's not writing correctly. Theta 1, and this is theta 2. Okay, so we're going to do cosine of 50 degrees plus 100 degrees. And then we're going to do plus I sine the same thing, 50 degrees plus 100 degrees. So it'll look like this, 28. Now we don't need that bracket anymore. So it'll be cosine 150 degrees plus I sine 150 degrees. And we're going to leave our answer in polar form, so you're done. And for B, it's in radians, but you do the same thing. So to find the product, and now you notice R1 is 1. I'll write it here. And theta 1 is pi over 6. R2 is 1. And theta 2 is pi over 4. So we have R1 times R2 cosine of pi over 6 plus pi over 4 plus I sine pi over 6 plus pi over 4. Now, you know we're going to have to get a common denominator. So I'm going to change them both to 12s. So this is 2 pi over 12 plus 3 pi over 12. And the same thing over here. And so you're left with cosine 5 pi over 12 plus I sine 5 pi over 12 is our answer. Okay, dividing the quotient of two complex numbers. And they're already in polar form, same setup. And to divide them, you always do Z1 over Z2. So to get the formula, you do R1 divided by R2. Now we are subtracting. So it's kind of like, when you multiply, you add exponents. When you divide, you subtract. So that's what's going to happen here. So to find the quotient, we're given Z1 and Z2 for example 2. So Z1 divided by Z2 equals, I'll do the same thing. R1 is 50. R2 is 10. Theta 1 is 80 degrees. Theta 2 is 20 degrees. Okay, so you have to do R1 divided by R2 times cosine theta 1, which is 80, minus 20, plus I sine 80 minus 20. So I'm going to go ahead and divide. I'm going to get 5. And then this will be cosine of 60 degrees plus I sine 60 degrees. Oh, we don't need brackets anymore. You only have brackets because they don't like to do 2 parentheses. Okay, our last example this is just in radians. So R1 is 12, R2 is 4. Theta 1 is 3 pi over 4. Theta 2 is pi over 4. Alright, so to do Z1 divided by Z2, you follow the formula. R1 over R2 times cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So simplifying this, you're going to get 3. And look, our denominators are already the same, so they made it easy for us. This will be cosine of 2 pi over 4, which is pi over 2, plus I sine, same thing, 2 pi over 4, which is pi over 2. And then we are done. So leave your answers in polar form.